All right, let's talk about half-lives. Half-lives, remember, we've kind of discussed the idea relatively quickly about the idea of half-lives and the importance when we're talking about radioactive isotopes. But let's take a look at it a little bit further. So, half-life says, so how long does it take for these isotopes to decompose? That's why we kind of take this idea of half-lives into consideration. So, let's look at half-lives. Half-lives in essence, well, we have radioactive materials undergo nuclear decay at a constant rate. So it doesn't fluctuate, it just stays the same. And depending on if you're going through alpha, beta, or gamma, which you could also have electron capture or positron emission, depends. All these are different types of radioactive isotopes. And so the half-life is the time it takes for half of the sample to radioactive decay. So what is half-life? It's the time required for one half of the sample to radioactive decay. In other words, half-life is the time required for one half of a sample to radioactive decay. So let's take a look at this, just an example. I have a cookie. You're like, oh yes, cookie. Before night 1, I had 100%. If my half-life was 1 day, night number 2, I would have 50% of a cookie, and 50% would be gone. Night number 3, half of the 50%, so I'd have 25% of the initial 100% remaining. 75% of that cookie would be gone. The next night, 12.5% is remaining of the original 100. 87.5% is gone. Cut it down in half again. 6.25% is remaining. Cut it in half again. So every night, half of it goes away. And so as you see, it decreases by half every half-life. And for this cookie, it would be 1 day is the half-life. If we were to apply this to more real-life situations, let's just take a look. The half-life of iodine-131 is about 8 days. This means in 8 days, half of the sample would remain. So here's just a question. If you start with 200 milligrams of iodine-131, how much would remain after 8 days? So we've noticed that the half-life is 8 days. So after 8 days, half of it would go away. So if you're sitting there thinking, oh, I start with 200 milligrams, one half-life, which is 8 days, I would have 100 milligrams. Let's take this even further. So instead of just saying after 8 days, let's say how much would remain after 32 days. So after the second half-life, which is another 8 days, I would have 50 milligrams. After a third half-life of another 8 days, I would have 25 milligrams. After a fourth half-life, which is another 8 days, which totals to be 32 days, I would 12.5 milligrams. So you can look at it and kind of logically just work your way down and break it down. 50%, 50%, 50%, half of it goes away, half of it goes away. Or we can utilize a formula, which we all love. So A equals A naught times 1/2 to the power of H. What in the world are these things? A is the final amount, A naught is the initial amount, and then 1/2 to the H, that's the number of half-lives. So how can you figure out the number of half-lives? Well, H, or the number of half-lives, is the time passed divided by the time of each half-life. So for our particular example, where I said instead of 8 days, we said 32, you would have 32 days, this is the time passed, divided by 8 days per half-life, you would have 4 half-lives. So if I take this and plug into this formula, I'd say my initial amount is 200 milligrams times 1/2 to the fourth. That fourth is the number of half-lives, which is 32 divided by 8. You do that multiplication, and you end up getting 12.5 milligrams, which is the same as kind of just working your way through logically and cutting it half and half and half and half. So let's skip that one. Here's another example. A certain radioactive element has a half-life of 32 days. If my original sample had 800 grams, how much would remain after 160 days? So things to kind of take into consideration is that 160 days, the amount of half-lives the amount of time per half-life is 32 days. So I'd say, okay, 160 days divided by 32 days, I have 5 half-lives. My final amount, I don't know. The original amount was 800. I'm going to multiply that by 1/2 to the fifth, which is that H value. A times 800 times 1/32, in essence. You'd end up getting your final amount of 25 grams. So in looking at this, you have This is what you would end with. This is what you started with. If you really wanted to, you could say, okay, 800 grams after one half-life, which is 32 days, I would have 400 grams. After another day, I would have 200 grams. After another day, I would have, or another 32 days, I would have 100 grams. 32 days, 50 grams. 32 days, 25 grams. So 32 days, 32 days, 32 days, 32 days. That ends up being 160 days all. And so you can kind of just work your way through in half, in half, in half, in half, in half, if you want to work your way through that way. So just kind of get this general idea. If you look at the initial amount, you can determine how old something is or how long something's been around if you know the half-life. And what we could do, if we wanted to get a little crazy, would be I could give you the final amount, the initial amount, the half-life, and then the time it takes for each half-life, and you can figure out how old your things were. That would be very honors, so maybe we'll get to that. Anyways, hopefully that was helpful. I have a couple questions for you guys, and let me know if you have any questions for me. All right, have a good one.